Good morning and good afternoon, everyone. Welcome to the webinar, Leveraging Artificial Intelligence to Advance the Renewable Energy Sector in Asia Pacific. Together with the Empower Women for Climate Resilient Society, the CTCN Technology Center and Network is delighted to welcome you to this capacity building webinar designed for the regional and national renewable energy actors like you to understand how to advance the renewable energy adoption in the Pacific and Asia region through artificial intelligence, AI. For the next 1 hour, we hope to present knowledge from CTC network members with AI specialization to you for your understanding and consideration of AI application in your respective work. The session will be recorded for your revisit and redistribution amongst your network. It will be available on both Empower and CTCN websites as well as our YouTube channels. So prior to this session presentation, we would like to welcome you to complete a short Menti question. So I have my colleague from UNEP ROEP for the Empower program, Alex, to present the questions to you. It may pop up on your screen, or you may either follow the link that will be shared through the chat box. The first question is up there. I will go for great. And you can follow the next link to complete the survey. Give us the thumbs up once you completed your survey. We'll wait a couple more seconds for you to complete the survey. Alrighty. Let us move to the presentation. The first presentation you receive today will touch on a very fundamental question on the use case of AI technology in climate projects. What are the available AI technologies that can be adopted by the renewable energy sector? As to increase your awareness of using AI to developing renewable energy solutions, I hereby delightfully introduce our first speaker, Joo-hee Lee, a manager at VeryWords. She has worked at VeryWords since 2020, specializing in overseas project coordination and management support. She is currently involved in an e-mobility project in Cambodia and Southeast Asia. She's focusing on sustainable transport projects in Cambodia and development. Her presentation title is Beyond Limits, the Next Big Movement, E-Mobility Ecosystem, and a Glimpse of AI Technology Integration. Let us give us a warm welcome to you, Joo-hee. The floor is yours.
Thank you, Miss Kim, sorry. And my name is Joo-hee. And just like she introduced, I'm a manager at VeryWords, and it's my great pleasure to introduce the VeryWords project and our AI technology integration case today. So let me share my presentation. 1 second, please. Can you see the screen? Okay. Okay, so today I'd like to share my company, VeryWord, and also how we integrated the AI technology into the e-mobility sector. And I'd like to share 3 parts. First is the overall introduction to VeryWords. And second is our main business model and technology. And lastly, the AI technology, how it is integrated in our e-mobility sector and our business model. Okay, so Verywords basically develops carbon reduction business models and implements them to achieve a carbon neutral society. The company actually started as a consulting firm in the beginning, but has now expanded into different areas. And currently we focus on e-mobility project and the entire e-mobility ecosystem, from the production of e-mobility to the battery recycling. And now let me share the background and business opportunity of e-mobility project. As we all know, we have a universal goal of preventing the rise in CO2 emissions and keeping the global warming below 1.5 degrees Celsius above pre-industrial levels. And in line with this, Korea has also set the GHG reduction targets, and part of this reduction must be secured from overseas. And additionally, from a market perspective, Southeast Asia area is very attractive region for e-mobility due to its huge market size and potential. It is 100 times bigger than Korea in terms of scale. So from our perspective, Barrier's perspective, implementing an e-mobility project in this region is advantageous, both for global and Korea greenhouse gas reduction, and also for tapping into the best e-mobility market. So since 2019, Verywords has developed the e-mobility business model funded by Korean government. There are a few stepping stones and milestones. For instance, in 2019, we started our first pilot projects. And in 2022, we opened a cultural complex charging station, the Papo station. I'll show you later in this presentation, in Siem Reap, Cambodia. And in 2023, we opened an assembly factory in Cambodia. And last year, we launched a carbon reduction project. And through this project, we can now also secure carbon reductions. Essentially, Verywords developed the business model through government funding and strategically utilize that support. Okay, so here is the Papo station and cafe in Siem Reap. And this was funded by Korean Energy Agency. And you can see this charging station and solar power. So this e-mobility is basically charged from this solar power panel. And also we launched a tour program using this e-mobility. So people or the tourists can ride our e-mobility and tour around this Angkor Wat area. And in 2023, we set up an e-mobility assembly factory and also a battery recycling factory. So recently, we changed the production line to a continuous system to scale up the production for further or future expansion. And as I mentioned, last year, the Korea-Cambodia Cooperative Framework officially began. And based on this bilateral cooperation, Verywords will secure carbon credits or greenhouse gas emission reduction from the project and use them to meet carbon reduction goals as well. Yes, so here is an MOU. And I'll move on to the next part, which is the Verywords technology in depth. So currently, Verywords focuses on e-mobility technology. And what we found in the beginning is that there are some hurdles preventing people from using e-mobility. So the first one is basically it's too expensive. The e-mobility, they're too expensive, non-affordable. And the charging is inconvenient because it takes a long time to charge, and it's hard to find those charging stations. And third issue was that the waste battery issue. So after using all the e-mobility, the batteries, waste batteries will come out, but we didn't have any solution for it. So we just defined these are the hurdles and problems of e-mobility. And so Veryworks worked on solving these problems to lower the barriers. So the first one was that we reduced the cost by retaining batteries ownership ourselves. So we only sell the e-mobility body to those customers, but we keep the batteries and we manage the batteries ourselves. And second one is that we installed more station and we made various types of charging station so that we can spread those charging station and make those make it like easily accessible to those users. And third one is that we came up with a solution for waste battery, the local recycling center. So this is an overview of Veryworks business model. So we produce electric motorcycle and supply them to the customers at affordable price. And for those batteries, we let our customers to choose the subscription plan. So we own and we manage the battery, but the customers, they can choose the plans like battery plans, and then they can pay monthly to use our batteries. And after usage, the waste battery are sent to those recycling center, and we manage those recycling and reusing process as well. And all this data from this entire business model is monitored and stored, and then used to calculate the emission reduction. Sometimes it's sold to other companies, and also it's used for AI learning, so AI learning data. Yeah, so the slide shows the overview of various products from e-mobility to charging stations, and also our Popple station and the battery recycling center as well. And as the charging station are very critical and important in this project, more charging stations will be installed in Cambodia for successful implementation and promotion of e-mobility. And here is an image of Popple Station 2 and also our mobile e-station. And finally, with this all background and information, let me share how we integrated AI technology into our current system. Right now, Veryworks is also in the beginning stage of integrating the AI technology into this current e-mobility. So it's a bit conceptual. We still have a lot far away to go, but yeah, I'm glad to share what we're planning to do, and I hope it can give you a glimpse of insights at least. Okay. So right now, there are two main areas where Veryworks is considering AI integration. The first one is battery, and the second one is e-mobility. So before I get into this, let's recall the basic concept of AI. I might be not like correct, but it's like just for your reference. So AI needs to collect huge amounts of data and do machine learning to analyze it and find or create patterns or algorithms, right? And with this afterwards with human feedback and corrections, the algorithm becomes more accurate and smarter. So that's the basic concept. And we basically integrated this AI technology into two areas. First is batteries. So especially the battery evaluation, battery performance evaluation area. So originally, after batteries are just used, those waste batteries are sent to the recycling center, and those batteries should go through the evaluation stage. So see how the state of health or state of charge, those kind of things are um, checked in those recycling center. But it takes a really long time because it should be done by repeating charging and discharging over and over again. But with this AI model, uh, we can make this battery performance evaluation more efficient. And the other sector is the e-mobility sector. So when drivers use e-mobility on the road, extreme environmental conditions or irregular traffic flows and unsafe driving habits increase accident risk. So to lower this accident risk, we started development of AI-based customized safe driving system. So that's the two basic concept of AI integration technology. So for the first one, to explain the AI-based diagnostic system or the battery performance evaluation system, first we collect data and process it, which is used to design and train the algorithm to predict a state of charge or state of health of the batteries. And this algorithm-based program will be installed on some type of hardware, just like this type of hardware. And by simply putting our batteries into the system, the status of waste battery will be analyzed and displayed. So without just repeating charging and discharging process, we can just simply put in batteries into this hardware, and then it will analyze the status or the state of batteries. And then the algorithm is already installed in that hardware. So that's how it works. And also, this can be used for renewable energy sector, especially for ESS, energy storage system as well. And for the second one, customized safe driving guide for e-mobility. Again, the first step is collecting data, such as driver driving patterns and behaviors via various sensors and IoT modules. And like I shared before, we already set the platform like a system. So we're collecting all the data from there, and then we have secured all the data for AI learning in the very beginning. And next, we design and we train an algorithm to analyze this data and predict accident risk. So yeah, like kind of processing all this big data and make it into meaningful algorithm. That's the second step. And once the model is complete, its applicability will be tested and we can deliver safe driving guidance via mobile app. So it's pretty simple. Collect data, just design and train the algorithm, and just let people use it. But even though it's simple, I know that step 1, 2, it's very long process and a lot of technology and a lot of study should be done. So yeah. And so with this, by integrating AI into our e-mobility system, we will streamline the battery diagnostics, deliver real-time safe driving guidance, and dramatically reduce the accident risk. And I believe that with this AI technology integration, we're not just simply improving the e-mobility, but we can drive the next generation of cleaner, smarter, and safer e-mobility. Yeah, so thank you very much for your attention. That's all for my presentation. Thank you.
Thank you, Julie, for your presentation. We will address all questions at the end of the webinar. So for the participants, please freely use the Q&A platform, which is on top of your screen, to leave your questions there, or you can also put it in the chat box if you find it difficulty to access the Q&A platform. As we've seen from Julie's presentation, we are seeing more and more efforts of climate business owners to apply AI technology to enhance the overall quality of their existing solutions. Application of AI technology can happen at very small scale. It doesn't have to be a high tech, for example, like enhancing very words battery performance and e-mobility to smoothen consumer engagement for safe driving. So Juhi's presentation perfectly nailed on those two application of AI technologies at a very local scale in further to enhance their solution. Our next and final guest speaker is Dr. Yoon-Soo Kim, who will address the second key question on how can AI be applied to implementing regional and national renewable energy policies and action plans in an inclusive manner. In order to build capacity to harness AI for locally led renewable energy solutions, Dr. Kim will provide a brief introduction to the AI technology concept and mechanism, and also share his ideas on what policymakers should do based on his own experience. He is a former senior researcher at Korea Electro Technology Research Institute, director of the Korean Society for New and Renewable Energy, and the Korean Institute of Electrical Engineers, as well as a Fulbright visiting scholar at the University of Hawaii School of Law. He joined the faculty of Gwangju Institute of Science and Technology in 2018, where he is currently a professor in the Department of Electrical Engineering and Computer Science, and his interest includes distribution network, energy management system, optimal bidding strategy, microgrid, and AI application to energy system. So no further ado from my side, let us welcome Dr. Kim. The floor is yours.
Thank you for the introduction. Let me share my slide. Can you see my slide?
Yes, we can.
Okay. Hello everyone. I'm Yoon-Soo Kim, a professor at Gwangju Institute of Science and Technology, or GIST. It's a great honor to give a talk today about a topic that is very, very close to my field, where I am very interested in, which is building capacity to harness AI for locally led renewable energy solutions. Since I heard that most audiences are not having deep technical knowledge on AI and energy, so I won't dive deep into technical aspects of AI and energy, and it'll be also be boring if I dive deep into techniques. So instead, I want to focus on three key concepts, which are AI and local and solution. And by connecting these concepts, I would like to derive my own conclusion for the locally led renewable energy solution, which will be my suggestion for AI policy. So through this talk, I will share some of the lessons I've learned from my own research journey, especially the challenges and opportunities I've encountered while working on energy systems. So let's begin with the word solution. At its core, a solution is just simply the answer to a problem. So we are finding an answer to our problem. So in many disciplines, including energy, we can express problems in very, very simple terms, as shown in this slide. So so our problem is to we are trying to either minimize something bad, like carbon emissions, or maximize something good, like social welfare. So if we transform this problem into a mathematical equation, this usually involves deciding on the best value of a control variable, often written as x. And this x depends on who you are and what you control. So in other words, different people or institutions have different decision-making powers. So let me walk you through an example from the energy field, especially power systems, which I am familiar with. As you can see here, a power producer problem is to maximize profits. So to do that, they adjust how much electricity they generate. That's their control variable, and when to generate. So their solution is the generation schedule, how much power to produce at what time. And on the other hand, a consumer wants to minimize their electricity bill. So they may choose when and how to use electricity more efficiently. So both sides are optimizing, but in different directions and with different control variables. So now, above both of them is the power system operator, who oversees the whole power grid. So their challenge is to minimize the total system operational cost, which includes things like fuel costs and maintenance costs and even societal costs. So one of the major example of this societal cost is the resistance from communities when a new transmission line is built. And people may oppose it due to concerns over landscape or property values or safety. And this brings us to the cost of uncertainty. Particularly relevant when we talk about renewable energy. Actually, renewable energy, the renewable energy has very, very high uncertainty costs, and this uncertainty costs is directly or indirectly related to the other costs like fuel costs and maintenance costs. Unlike fossil fuels, renewables like wind and solar are highly variable and difficult to predict. So their uncertainty affects every cost I just mentioned. So if we want to expand renewable energy, if we want to increase the penetration level of renewable energy in power grid, we need solutions. We need solutions that deal with this uncertainty as well. And that's not all. Actually, beyond the power systems, there are other energy domains like gas and heat systems, each with their own optimization problems. And above all of these levels, we have regulators. And their goal is to maximize social welfare through policies and regulations. So their problem is to maximize social welfare, and their control variable might be policies and regulations, and how to control it might be their solution. So they decide whether to impose tariff or not, how much to charge, and what kind of incentives or restrictions to apply. Those kinds of can be their solutions, and they are AI policies. So these decisions involve an enormous number of constraints and trade-off, as shown here. So basically, these problems, the world's problems are incredibly complex, and modeling them, like I showed you before, modeling them into some kind of equation is extremely difficult, even for experts. And that's where AI can help. So basically, instead of asking humans to model these complex systems directly, we can harness AI to learn the models from data. So, and AI is especially good at handling complexity when given enough examples. So, for instance, take the task of identifying fruits in pictures as shown in this slide. Imagine trying to write rules to classify them based on shape, color, and texture, which can be represented into mathematical equations actually. And trying to those things would be a nightmare. So there are just too many variables, like lighting, angle, background, too many variables. But AI can solve this instantly if it has enough good data. So we don't need to put our effort to complex modeling, but have to put our effort to collect and manage various data. I think this is why engineers like AI, because they do little thing than before. So the same goes to for robotics. You may have seen this robot in videos. It is sensational. It can climb stairs. It can jump, dance, and keep perfect balance. It's incredibly impressive. About 20 years ago, just making a robot walk on two legs was considered a breakthrough. Now we've come this far, all thanks to AI and data. But here's something important. To get to that level, as shown in this figure, to get to that level, the robot had to fail thousands of times. And that's okay for robots. Robots can fail. They learn from it. AI learns just like humans do through failure. But what about energy systems? We can't afford that kind of failure. A blackout or failure in the energy grid can have huge consequences economically and socially. So we don't have failed data, and even collecting normal operational data is very, very difficult. Why? Because the systems are huge, very, very huge, and distributed and extremely complex. So let me share one of my own projects as a case study. This figure looks a bit complex, but you don't have to be focused on this. I'm currently working with KEPCO, Korea Electric Power Corporation, which is the only electricity utility in Korea, to forecast regional electricity demand up to the year 2050 using AI. So now, in order to train AI models, we needed detailed regional data. So I want you to focus on this picture. We collected this data from KEPCO and the National Open Data Portal and various other local government systems. But here's the problem. As you can see, the shape of each block don't match. The data didn't align. The time intervals were different. The formats were different. The units were different. Even when we added up the regional totals, they didn't match the national data. So in the end, my team spent almost 70% of total research time just for cleaning and aligning the data. So from this experience and from many others like it, I've learned two major lessons. First, as you all know, data is everything. But in the energy sector, where failure is not allowed, data is more than everything. It must be accurate and complete and reliable. And second, the energy system is so large that it's nearly impossible to manage all this data at a central level. So the data should be produced, collected, and managed locally. But for that to happen, we need to define what a local unit is, and we need to build interoperability between regions. So this means aligning formats and types and units and many other things, and maintaining those standards over time. That is very, very important. So let's revisit the diagram from the earlier page, the hierarchy of problems. Even though the energy system is complex, we can break it into smaller subproblems. Smaller problems are easier to manage. The same principle applies to data. Energy data is being generated every second, everywhere. We can't manage all of it at once. So we manage it at the national level, then the regional level. But again, the key is interoperability. If one region's data can't used by another, then we lose the power of AI. That's why I believe locally led renewable energy solutions must start with locally managed and interoperable data. So to summarize, the big goal in energy is to maximize social welfare. And if we zoom in on renewable energy, we face specific sub-problems. And these problems are still very complex, so we turn to AI for help. But AI only works if we have good data. So in the energy sector, this data must be locally produced and managed. That means we need to define what local means and build interoperability across regions. And I strongly believe that this should be done by AI policy, which is my key suggestion today. And this is how we make sure AI remains useful in the long run, not just today, but in the decades to come. I am Yoon Kim, and I've spent my career working to solve energy problems through mathematics and AI. If you are curious about this presentation or want to talk more about energy and AI, please don't hesitate to reach out using the contact information shown here. Thank you. Thank you very much for your time and attention.
Thank you, Yunshu, for your presentation on the key concepts of AI, local, and solutions. With the formula minimizing cons and the maximizing pros, driving a clear example of problem identification. What struck me the most was the approach that you have taken, which is the use of AI to reduce the cost of failure, especially in the renewable energy, because that is not acceptable. And the example that you presented, which is working with Korea's electricity company KEPCO to predict the electricity demand with AI, that really highlighted my question about what is the perfect data and what factors should be added for us to collect the locally perfect data. Although I do believe there is no perfection in our daily practice or as a living, but it did enlighten me to think of what is the data that we should include in our AI application for renewable energy transformation. Thank you so much for that. The next session is a Q&A session, and I have seen no question actually from the audience, but given that we have a small amount of people who are here today to have this interaction with you, with you too, Juhi and Yunsu. I would like to welcome the questions from the audience. If you have the question that you want to raise to both of our speakers, please do raise your hand, and so we can let you in for your immediate question. We'll wait for like a couple 2 minutes, and then if not, we'll move on to the mentee post question. So if you have any questions, please raise your hand. Or any feedback or comment is also good. Sonam, yes, please put up your speaker and do pose the question or feedback or comment. Thank you.
Good morning. Sonam from the International Center for Integrated Mountain Development here at Kathmandu, Nepal. Warm greetings to all of you. Thank you for two brilliant presentations. I have a question for Professor Yoon-Soo Kim. Thank you, Professor. Excellent presentation and very, very helpful. I work with a lot of most marginalized women, persons with disability, socially and economically disadvantaged groups, communities at Hindu Kush Himalayas in this part of the world. So lately I've been working with the Bhutanese herders, yak herders and Nepali yak herders. Most of them, they suffer from indoor pollution and lack of firewood in the face of climate change. So we were toying with the idea of renewable energy. Of course, they're not connected with electricity grid. They're in the mountains. They're still using fuel wood. So you talked about social welfare. How would it be to, my question is, can we build locally accurate, reliable data and then look at tapping onto solar or wind power, depending on this particular village or the region, and then make women, children, elderly friendly solar panel so that it supports cooking, charging their mobile phone, using their small machines like cheese making, milk churning, butter making machines. Thank you very much.
Yunsu, if you'd like to respond, please do so. Thank you.
Yeah, actually, renewable energy has many advantages but also many disadvantages. Advantages are it's cleaner than the other sources, and basically it's distributed generation. So even if it's not connected to the electricity grid, we can still use it. But the problem is we cannot use the source that fluctuates. If output power is fluctuating, that actually we cannot use it. So we need the electricity grid to be connected to the renewable energy. So but in case of in case that we cannot we cannot connect it to the grid, we are using energy storage systems like batteries. So, but batteries are very expensive. So I have actually no clear answer for this problem. But I think there are advantages and disadvantages. So actually, what I'm trying to do is to find somewhere middle point of this answer. So, and maybe one of the ways that we can break through this problem is to mitigate the fluctuation of renewable energy, and if uncertainty is predictable, and that is no longer uncertainty, and actually that prediction, AI performs very well at prediction. So I hope if connecting to the electricity grid is very costly, I think our alternative is to gather those renewable energy fluctuation data, and gather the energy usage of people, and gather those data locally, And if you gather that data, nowadays it is very, very easy for everyone to use AI. So if you gather the data and if you can use that data for AI, maybe then we can renewable energy can be more predictable. And in that way, maybe we can solve that problem step by step, a little by a little. So that's what I hope to see.
Thank you very much, Professor. I hope to stay in touch with you. Thanks.
Thank you.
Thank you.
Thank you, Yunsu. We have another hands up, which is from Tino. Did I pronounce your Tito? Pronounce your name correctly? If so, please do pose your question.
Yes. Good afternoon. I'm from Timor-Leste. I'm speaking from WHO control from Timor-Leste. Can you hear me well?
You're a bit breaking, but I did hear WHO in your name, Tito.
Hello. Hello. Hi.
Hey.
It is clear now.
Yes.
Yes. So I just have a question for what maybe can help. How can we integrate the AI into the health system? Then what kind of model can I use for it? So that will be great if we can just forward some knowledge of this. Thank you.
Thank you, Tito, for your question on how can we integrate AI for health issues. Maybe I can pose that question to Juhi, given that she did mention about planning forehead. That very words is planning to integrate the behavior and knowledge data coming from the local to enhance the overall product. But if there is any streamline of health issues related to safe driving, I think you can elaborate a little bit from there. Thank you. So Juhi, over to you.
Okay. So maybe I can explain or elaborate how we're planning to integrate AI technology into the safe driving guidance. Probably that's also related to health. Yeah. But what we're trying to do or planning to do right now is that so on e-mobility, we're planning to develop different sensors. It's pretty hard to remember, but it's like a gyroscope sensor that if I remember it correctly. But that's the sensor and that makes the driver to keep the balance. Yeah. And also there are different, like the speed or driving speed is also like monitored on the e-mobility, and all those data will be monitored and sent to our data server through IoT system. And what we're planning right now is that with that data, maybe real-time data, the AI, AI will kind of collect the data and judge or like see if it's safe right now for the driver. So if senses or if it catches any data that kind of signals it's not in the safe status, the AI can judge that situation and send the alert and alarm to the user. Yeah. And also, if it's developed even more, I believe the AI can directly give signal to the e-mobility system so that the e-mobility can just automatically keep the balance, like preventing the e-mobility from tipping over. But I think that's kind of future technology for us. But we're still on the way to developing that technology. So I hope this answers your question.
Thank you.
Yes,
We do.
Thank you. Maybe can I have just quick. I think that this the interesting system. It's related to. I saw some presentation related to the transport, public transport, like you saw the motorbike that can utilize this AI. That that will be it's helpful for how to integrate what to monitoring the air pollution for public transportation. So what kind model can we adopt it to like can you have some examples from your side? Thank you.
Thank you for your additional question, Tito. I think we're getting similar questions from other audiences as well regarding the types of LLM being used in Yunsu and Juhi's products or their solutions for the AI implementation. Although we do know that from the previous discussion that models are developed in the phase of developing and whether it's for the sustainable mobility or electric usage, given the collection part takes up the large chunk of the budget and the resources. We hope these models to be open source in a longer term to enhance the collective effort in greening the system for the renewable energy sector. But I would like to pause back to Yunsu and Juhi for a brief intervention on what are the models that you are under developing, including the LLM, as well as the follow-up. Did you fine-tune the model on your data, and how was the experience behind that? Thank you. So over to Yunsu and then to Juhi. Thank you.
Okay. Yeah. In my case, actually, I am not using LLM model very actively in my field because in my field actually numbers are the things that matter because and in my field most of them are time series data. That is the data that that is generated every second. So for example, the market price data. There is a market for electricity, like stock market, and the prices keep changing. And there is, like I mentioned earlier, there is renewable energy power. It's time series data. So usually I am using the model that works best for time series data forecasting. And conventionally, for the time series data forecast, we used the model named LSTM or GRU, something like that. But recently, GPT, the ChatGPT you are using, the GPT integrated every type of problems. So that there are some modification from GPT, like for time series model, they developed time GPT, and for the other things, they develop some other model that is based on GPT. So yeah, so it depends on problem. If it's time series data, I am using time series model, and if it's image data, I am using some model that works for image. Conventionally, the model named convolutional neural network works best for that model. But I think recently there are so many models, and whether your data is number or word, it also matters. So in case of the data is type of word instead of numbers, then you have to use the models that is called like CatBoost or XGBoost, something like that. And I actually am using LLM for LLM to recommend me what model to use. That's maybe the only case I am using LLM in my study. Yeah.
Thank you for your later intervention there. Juhi, would you like to add something from your end? You're on
Okay.
mute. Yeah.
Okay. So I think that's a very technical question. And sorry, I don't think I can provide you any good answer to it, fortunately. But I'll check it with our tech team. And then if I can follow it up later on, yeah, if needed. Yeah, thank you.
Yeah,
Thank
I just
you.
want to add one more comment on the previous question, because the question includes the tuning of the data, but I didn't mention it. Regarding the tuning of the data, actually, ChatGPT recommended me to how to tune the data also. So based on its recommendation, and I also have another expertise on that tuning method. So I am using the recommendation from GPT, but I can also have some knowledge of how to tune. So maybe there is some collaboration between me and GPT's recommendation.
Interesting, very interesting. Thank you so much to both, as well as the audience, those who posed the question. Due to the time limit, we cannot discuss furthermore, but I think the questions that are posed by the audience actually gives a good insight to the organizers, including my dear colleague Alex here, for a future webinar to be presented for you. Specific to the urban energy planning question, as well as the discussing on the key technical challenges in building a quality data set for AI training. Those are great questions that we will look back to it and then start designing the webinar around those two questions. Thank you so much for the input there. Before we finish, we would like to pause the Menti question. But before that, I would like to give a round of applause to our speakers. Please do use the reaction function over here to give a good applause to our two speakers. This webinar will finish with the Menti post survey, as well as I will welcome Alex to give a brief introduction to our next webinar and close the session. So the post questions are paused to you at this moment. 2 questions. Thank you very much for completing those post questions. So the floor is over to you, Alex, for your closing. Thank you.
Thank you. Right, yeah. So just thank you so much as well to everyone who has joined to listen in on AI and how we can integrate it in renewable energy. Also, special thank you to the two speakers, Yinsu and Buhi. So just to give a teaser of what we'll be touching on tomorrow, we'll dive into how gender equality and social inclusion, just like AI, can be an enabler for advancing renewable energy adoption and ultimately building climate resilience within Asia Pacific. So we'll be hearing from the Empower program, which is a joint initiative between UNEP and UN Women, which is the main objective of the program is to build climate resilience through marginalized communities and women at the helm of adopting renewable energy initiatives. And so we'll look at how this has been a success in advancing renewable energy, also leveraging climate finance and expanding livelihood opportunities, working with different stakeholders like governments and financial institutions, as well as local communities. So we hope that this will be enticing for you to join and also understand what CTCN's policy on gender is about and how we can collectively use gender principles towards advancing our objectives. So looking forward to seeing all of you tomorrow, hopefully. And yeah, thank you. If there's any other questions, please feel free to reach out to either one of us. We'll be happy to follow up with any questions or concerns that you have. Thank you. Over
Thank
to
you,
Jiwon.
Alex. Yes, thank you, Alex. And thank you
Thank
again
you.
to our speakers
Thank you all.
and the audiences.
Thank you.
Recordings will be
Thank you.
available later,
Nice
so
to
please
you.
do revisit if you like to. Thank you
See
very much
you
for your
next
time
session.
today. Have a great
Bye.
rest of the day.